So in this video we're going to have some practice problems relating to polar arc length, and let's start with this fairly trivial question. What's the circumference of the circle described by the equation r equals 2? And right ahead you guys could be like, oh, we know the equation for the circumference of a circle, 2 pi r equals 2, should be 4 pi. Well, let's try to figure it out using our arc length, and now that we know the answer, which should be 4 pi, we can check ourselves, so let's go ahead and do that. Here's just a reminder of the equation of the arc length formula. So let's find out what this dr d theta squared and what this r squared is. Let's start with r squared. That one's easy. If r is 2, r squared is 4. Our dr d theta, the derivative of 2 with respect to theta, that's just 0 because this is just a constant. So dr d theta squared is obviously just going to be 0. So let's go ahead and solve for our arc length. If we're looking for the circumference of the whole circle, well, a circle starts at an angle of 0 and goes all the way 2 pi around. So that's going to be our limits, 0 to 2 pi. And we're going to have the integral of the square root of the derivative squared, which is just going to be 0 squared plus r squared. We solved for that. That's just 4 with respect to theta. And let's go ahead and do that. Turns into the square root of 4, which is 2. So we have the integral of 0 to 2 pi of 2 d theta, which is equal to 2 theta, because we just have this d theta. It's 2 is just a constant. And valuing that from 0 to 2 pi, plug in that, and you get 4 pi. So that's where you come up with the equation for the circumference of a circle. You could actually derive that. If you had this r just, instead of r equals 2, plug in x, you could actually come up with the equation of the circumference. So that's pretty cool. Let's go to this next practice problem. This one's a bit trickier. Trying to find the length of the upper half of the curve described by the function r equals 1 plus cosine theta. So I went ahead and graphed this already. If you don't know how to graph this function, you guys better go back to the graphing videos. So let's go ahead and do that. First, let's solve for r squared. If r is equal to 1 plus cosine theta, r squared is just going to be we have a cosine squared theta. We have 2 times cosine theta times 1. So we have 2 cosine theta plus 1 squared. That's just 1. So that's our r squared. Let's go ahead and solve for dr d theta. Derivative of 1 is 0 with respect to theta. Derivative of cosine theta with respect to theta is negative sine theta, which means that dr d theta squared, because that's what we're going to use in our equation, is sine squared theta. So now that we have all the components, we can go ahead and use the equation. We're only looking for the upper half, so we're looking from here to here. And I'll go ahead and mark what we're looking for. We're looking for that length right there. So this starts at an angle of 0, goes all the way to an angle of 2 pi, and we have our square root. Square root of the derivative squared, which is sine squared theta, plus our r squared, and yes, some of these questions can get pretty tough, and later after this video you guys might want to go ahead and review some trig identities, because this whole unit, it's really useful to know trig identities. So that's equal to the integral from 0 to 2 pi of the square root of, well, this sine squared theta and this cosine squared theta, that turns into turns into 1. So you have 2 cosine theta plus 1 plus 1. So we have 2 plus 2 cosine theta d theta. And now that's not really something that you guys could integrate without using trig identities. And notice that cosine squared theta is equal to 1/2 1 plus cosine 2 theta. It's a double angle formula. And we have 2 plus 2 cosine theta, so we kind of have 1/2 of this. So instead of theta, we have cosine squared of theta over 2, because that's going to give us 1/2 1 plus cosine of 2 theta over 2, which is just theta. And we have 2 times 1 plus cosine theta, or we have 2 plus 2 times cosine theta, and you're going to kind of have to tweak this equation to make it look like this equation. And after you do that, tweak this equation to make it look like that. After you do that, you should get, I believe you have to multiply this by 4, both sides by 4, and once you multiply it, you get a 4 over 2, 2, and that distributes out, so you get a 2 plus 2 cosine theta. So you're going to have 4 cosine squared theta over 2 d theta, and now we can get rid of that square root. So you have 0 to 2 pi of 2 cosine of theta over 2 d theta. And if we take the antiderivative of cosine, that's sine. So divide by 1/2, that gives us 4 sine. Angle stays the same. Value from 0 to 2 pi. I'm sorry. I had the limits wrong this whole time. Hope you guys noticed that. We're looking at only the top half, right? So that's from 0 to pi. So if we evaluate this from 0 to pi, we should get, well, let's see, 4 times sine of pi over 2 minus 4 times sine of 0, which is equal to, well, sine of 0, that's 0. Sine of pi over 2, that's 1. So we get 4 times 1. So there's your answer. That's the length of this upper half of the curve r equals 1 plus cosine theta. Once again, probably want to review your trig identities, and basically you just have to follow the formula of arc length right there, and shouldn't get, there aren't that many types of questions you can ask. The only thing that that people sometimes struggle with is finding these angles, like I did. You got to make sure the angles are right, and other than that, it's pretty much just algebra solving for the derivatives and for r squared.